Hi, I'm Eva Murphy from Electronic Engineering at IT Sligo, and this is my Leaving Cert Maths Grinds channel. I'll regularly add new videos for both higher and ordinary level maths, so make sure you subscribe below and click the bell icon to be notified of new videos. Right, on the 2014 sample paper on the Leaving Cert, the question for probability was as follows. The random variable x has a discrete distribution. The probability that it takes a value other than 13, 14, 15 or 16 is negligible. In other words, ignore it, okay? Complete the probability distribution table and hence calculate E of x, the expected value of x. So you'll see as you go down through the probability question, this expected value of x crops up quite a bit. Okay, let's have a look at our table. Discrete distribution, so we have set values with their associated probabilities, okay? The probability that it can take a value other than these is practically non-existent, which means these are the only scenarios that can occur, which means all the probability here has to add up to 1. So if you go 1 minus 0.383 plus 0.575 plus 0.004 or something to that equivalent, you should get the probability that the probability of x being 15. I'm just putting that into the calculator. And I got 0.038. Okay, so that was fine. If X is the age in complete years on the 1st of January 2013 of a student selected at random from among all second year students in Irish schools, explain what E of X represents. So expected value, okay, so E of X is always expected values. Okay, so if X is an age in complete years, explain what E of X means. So E of X is the expected value. I'm just reading it here now. Of a second year student in Irish schools on the 1st of January 2013. And the expected value is the average value or the mean value. Okay, whichever one you call that. You might call it mean value after you do stats, or you might call it average value, okay? So we can see basically that the majority of students in second year on the 1st of January are 14, followed by 13, and then much less 15 and much, much less 16. If the students are selected at random from this population, find the probability that exactly 6 of them were 14 years old on the 1st of January 2013. Give your answer correct to 3 significant figures. Okay, so that word exactly 6 from the 10 students makes me wonder, is it a Bernoulli trial? Okay, so do I have a set number? I do, it's 10. Is the probability the same? Well, yes, the probability that they're 14 is always 0.575. Is it an independent event? So in other words, if I select a student now and they happen to be 14, does that affect my chances of selecting another one? Well, not when I'm selecting at random. Okay, so that's okay. So yes, a Bernoulli trial. Okay, do I have a success and failure? I forgot about that. Yes, I can call selecting a 14-year-old my success, not 14 as my failure. Okay, so it falls into a Bernoulli trial. So out of the 10 students that I'm going to pick, I took that from here, I want exactly 6 of them to be 14. So out of the 10, I want 6 successes, okay? In other words, I want 6 of them to be 14. The probability of them being 14, so the probability of success is that, and I want 6 of them. So that's the probability that they're 14, and I need 6 of them to be 14. Okay, the probability that they're not 14 is 1 minus 0.575, and it's equal to 1 minus 0.575 is 0.425. So that's the probability that they're not 14, and I need 4 of them. Okay, so out of the 10 students, I have 6 of them that's age 14 and 4 of them that's not 14. This is the probability that they're 14, the 6 that's 14. This is the probability that they're not 14, and I need 4 of them. And 10 choose 6 is the way I would pick my 14-year-old, 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 not 14, not 14, 14, and of course I have 10 students. And of course, these 14-year-olds, the 6 that I'm going to have, can be scattered anyway, so anyway through how I choose them. In other words, I could pick 1, 2, 3, 4, 5 of them first, then not 2 of them, then the 6th one 14, and then of course 2 more that's not. Or I could pick 1 that's 14, then not 14, then 14, then not 14, then 14. And you can see there's a whole load of ways of choosing them. If you do 10 choose 6 on your calculator, you'll see in fact there's 210 ways where I can write down 6 14s and 4 not 14s. Okay, so thankfully you don't have to write all that out. NCR, that's how I put it into my calculator. The NCR button is behind the divide by sign, and that does it for me. So 10 choose 6, multiply by 0.575 to the power of 6, multiply by 0.425 to the power of 4 into my calculator, and I am getting 0.2476. 0.247618. 3 significant figures. Okay, well, that doesn't count as a significant figure. Leading zeros don't. So 2, 4, and of course I round up to 7. So it's 0.248 is the probability that I will get exactly 6 14-year-olds. If you've enjoyed this video, then why not join us in IT Sligo and use maths in practice. In conjunction with industry, we've designed an exciting new program in electronics and self-driving technologies, which uses cutting-edge techniques such as artificial intelligence, computer vision, and virtual and augmented reality. You'll need a H5 in maths to qualify. Check out the link below.